But let me just give you a little visual. So absolute value, because it's a distance, it's always positive. You can never have a negative distance. Like if you drive to Indianapolis and you drive back, you're not putting your car in reverse. You're coming back the way you came, but you're still traveling a distance. So if you're on the number line and you're a positive number, this is usually like, let's say I had absolute value of x and I said it was 3, right? So there's actually two ways I could do that. If I went from 3 to 0 on the number line, right, that distance would be 3. What's another way I could get to 0 on the number line with a distance of 3 if I started where? At -3. So that little equation, because if you start at -3 and go to 0 on the number line, that distance is also +3. So this little equation has two solutions. So it could be x could be 3 or x could be -3 to make that true. All right, so if you look at my little equation right here, absolute value of x, what number could I plug in for x to make it equal to 10? X could be what? 10 or -10. It has two answers. So if your absolute value, and let me just write this in general. If you have absolute value and it's equal to a positive number, you're going to have two solutions or two answers anytime that happens. Absolute value by itself equal to a positive answer or positive number is going to have two answers. So like it could be 10 or -10 that I plug in for x. Now, these are going to get a little bit more complicated as you go. The inside the absolute value is going to have maybe some more terms than just a plain x by itself, which we'll see in our first example. But you got to remember it's going to have two answers. Okay, so like absolute value by itself is equal to 6, so it's equal to a positive number. Okay, just pretend that nothing is in there for a second. Just pretend it's like a big X. If whatever is in there is 6, we would be good. If whatever's in there is -6, we would also be good. Okay, so here's all you have to do. When you get your absolute value by itself, which I don't have to do anything to make that happen here, you just take whatever is in here. Doesn't matter. If whatever that is 6, we're good. If whatever that is would be -6, when we take the absolute value, cancel out the negative, we'd also be good. So we're just going to set up like two little equations. So I'm going to do 15 minus 3x. If that was 6, we would be good. And then let me leave myself a little space. I'll come down and I'm going to copy exactly the same thing. But if that was -6, we'd also be good. So this is going to have two answers. And the equations are going to be similar steps to solve, but they're going to have two totally different answers because of the inside of that being, I got 15 minus 3x. We're going to do the same two steps to solve these equations, but the answers are going to be different. So like here, if I'm trying to get x by itself, I'm just going to subtract 15, right? I'd have -3x. 6 minus 15 would give you -9. I would divide by -3. And x would end up being 3. So there's one solution. So it just means if I plug in 3, and you don't have to go back and do this, but if I went back to the original problem, if I did 15 minus 3 times 3, right, that would give me 6. If I take the absolute value of 6, that is 6, that is true. The other answer is what I'm going to get if I solve the second equation I wrote, which it's just whatever's in your absolute value, you equal it to that number, and then you equal it to the opposite. So I did -6. Same two steps. We're going to subtract 15. It's going to look different here, though, because it was equal to -6, not +6. So -6 minus 15, I'm getting more negative, would be -21. And then I'm going to divide both sides by -3. And negative divided by a negative is always positive, so that would be 7. So what that means is if I plug in 7, like if you guys look back at that original problem real quick, if I plug in 15 minus 3 times 7, that would go in the absolute value. I'm just using using my calculator to do it, that would put negative 6 in this absolute value, but then the absolute value would cancel the negative out, so that's also true. So both of these answers work for this question. Two answers here. Okay, now I have a second problem. If your absolute value is not alone, which it's not in this question, I have absolute value x minus 5, and then I have a plus 3 equals 14. What you have to do is you have to get the absolute value all by itself before you try and break it into two separate equations. So I just have to do one tiny step here, and that is just going to be to move the 3. So then I'd have absolute value of x minus 5, and then 14 minus 3 is just 11. Okay, now I've got an absolute value equal to a positive number, so I know I'm going to have two answers. And all I have to do to get those two answers, it doesn't matter what's in here. You're just going to copy whatever's inside the absolute value. Doesn't matter what it is. If it was 11, we'd be good. Or if it was negative 11, we'd also be good because the absolute value would cancel that negative out. So just whatever's in here, I'm just going to break it into two equations. I'm going to say x minus 5 equals 11. And the other one, I'm just going to leave a little space, x minus 5, if that was negative 11, we would also be good. And if you wanted to check any answers when you do any of these problems we're going to do today, I would wait and plug it back into where you got the absolute value by itself. So if you want to check, like check after you got the absolute value alone, if you had to do it like we did in this question. Now, this is way quicker than the problem we just did. Literally, I just have to add 5. So one of my answers, 16. And if you think about that, plug 16 in for x, right? 16 minus 5, that's 11. That makes that true. If I solve the other one, I'm going to do the same thing. I'm going to add 5, but we'll get a totally different answer because of the way this was set up. So negative 11 plus 5 would be, let's see what, negative 6. Yes, you're totally right. Now, that means if I put negative 6, so negative 6 minus 5 in that absolute value would be negative 11. But then the absolute value would cancel the negative out. So both 16 and negative 6 work as answers. Okay, now I've got one more here. So the first thing, if you have any absolute value equation, you want to get the absolute value totally alone. This is super tricky, and I think a lot of times people are very tempted to subtract the 4 or the 2 from the 4 here. Don't do that. That 2 is being multiplied by that absolute value. So actually the first thing you want to do on this question, you want to move that 4. You're going to try and get the absolute value alone. That 4 is just subtracting 2 minus that whole absolute value. So get rid of the 4 first. It's positive, so I'm just going to subtract it. Okay, now with absolute values, absolutely we never distribute anything to an absolute value. You don't like multiply negative 2 into that. You cannot do that mathematically. Do not distribute or try to multiply things into an absolute value. So if I can't distribute that, which we don't want to do, does anybody know how I could get rid of the negative 2? Do what? Divide. Yes. Do not distribute. You want to divide. Do not distribute, divide. Divide by negative 2. The whole goal here is just to get that absolute value alone. So I get absolute value, x plus 9. Now, negative 20 divided by negative 2 is positive 10. So it has to be, your absolute value has to be equal to a positive number. We're going to talk about what happens next if that's not the case. But what you would do here, just whatever's in that absolute value. If that was 10, we'd be good. If that was negative 10, we'd also be good because the absolute value would cancel the negative. So you're just going to break it into two separate equations. One would be x plus 9 equals 10. Like just copy it down, drop the absolute value. The other one would be if x plus 9 was equal to negative 10. That would also be true. Now, both of these you're going to do the same math. We're just going to subtract 9, but I'm going to get two different answers when I do this. So one of them is 1. If you think about that, right? 1 plus 9 would be 10, and then absolute value, that would be 10. The other one, if I subtract 9 here, I'm subtracting it from negative 10, so it gets more negative. So it's going to be negative 19. And in that case, negative 19 plus 9 in here would give you negative 10 in the absolute value, and then the absolute value would cancel the negative out. So those are your two answers. So anytime you have absolute value by itself and it equals a positive number, 2 answers. Does anybody have any question?
Do you always have to put down both the solutions?
Yeah, because if you don't, you only have half the answer. Because there's 2 answers that'll work. Really good question. I was trying to think. Here, I'll tell you what. Let me pull up my Desmos really quick. I'm just going to show this to you guys on a graph, because you guys know what the absolute value graph looks like. Let's say I had y equals absolute value x plus 9, right? That was our question. I'm going to scooch my graph, but I'm going to show this to you. And that was equal to 10. Okay, if you look at that graph, do you see, so the V shape has 2 different solutions on there because it would hit 2 different times. There's 2 different values you could plug in to make that true. But visually, that's why you're going to have 2 solutions, because the V would run into that number twice. So that's what's going on with why you're going to have 2 answers to that question. I'm glad you asked that. Okay, now, let me have you guys look at this question. It says, does this equation have a solution? So I have 3x minus 4 in an absolute value, and that equals negative 10. I'm kind of like separating this from the other problems here. Does anybody know why I'm doing that? Like, what's wrong with that equation? I got an absolute value equal to negative 10. It's negative. Okay, so why can't it be negative? It has to be positive. Okay, absolute value makes everything positive, right? So, absolute value cannot be equal to a negative number. It's not possible. Absolute value makes everything positive. So if you have an absolute value by itself and it's equal to a negative number, this would just have no solution, because that's not possible. Think about that for a second. I'll pull the Desmos back up real quick and show you guys. So if I did, all right, so we had, what was it, 3x minus 4, right, in the absolute value. I wouldn't ask you to graph this or anything, but then it was equal to negative 10. And if I scrunch this so you can see the graph, like, here's my absolute value, right, my V shape, it never runs into this negative number. It's not possible. Anything above here we could have a solution, but if we got a negative number, it's not going to run into it, so there's no solution. That's just kind of like a graphic version of that, but that's why it doesn't run into it. So just for your purposes, if you get an absolute value by itself and it's equal to a negative number, you just stop right there, you have no solution. Okay, so we have absolute value equal to a positive number, 2 solutions. Absolute value equal to a negative number, no solution. The third option is what we're going to talk about down here, and that can involve what we call an extraneous solution. And I always like to tell people this. The word extra is right in the word extraneous, and it literally means you have an extra answer or an extra solution that doesn't actually work in the original problem. That's what an extraneous solution is. There's a couple different scenarios where we can have these, but for this unit we're just focusing on absolute values having extraneous solutions. Now, this is what I wrote here. An absolute value to have an extraneous solution can only happen if this is not going to be the 2 cases we just talked about, right? Absolute value equal to a positive number, 2 answers. Absolute value equal to a negative number, no solution. If you have an absolute value equal to an expression. Now, what I mean by expression, it has to have a variable. So like something like your absolute values equal, I'm just going to make something up, like 4x plus 5, or your absolute values equal to negative 3x minus 6, or something like that. That would be an expression. So it's got to have a variable in it. Okay, now the reason this is an issue is if you're equal to an expression, you don't know what the variable represents until you get your answers to check. So you have to make sure the expression is not equal to a negative number when you plug your answers back in. So you do have to check your solutions on this. So I just have a little example to the side, right? Okay, here's your example. absolute value 2x plus 12, and then on the other side, now this is an expression because it's got an x with it. So what you have to check is you have to make sure your expression doesn't end up being negative when you plug your answers back in. So this is how it works. You would just like we did in the other questions, copy the absolute, whatever's in the absolute value, drop it, and just copy, and then drop it and put the opposite. If you're working with an expression, you just make it the opposite. So this was 4x, so it's negative 4x. Solve it like you would a normal equation. Now, when you do this, and they wrote it out for you guys, they got two solutions, just like we did on the other questions. Here's the deal. And I always tell people this. You really only have to plug it in to the expression, because you can't have an absolute value equal to a negative number. So if you plug that number in and it makes that expression negative, then it won't work. So if I plug in 6, like right here, 4 times 6 is 24, so we're good to go, since that solution works if you look underneath. Now, if you look here, if you plug in negative 2 to 4x, 4x times negative 2 would be negative 8. If you go through, they did the entire thing. I usually just tell people just plug it into the expression. If it makes it negative, which this does, then that doesn't work. If it makes it positive, like 6 times 4 is 24, then you're good. If it doesn't, then you won't. So what happens here, you end up with the absolute value of 8 equals a negative 8, which is not true. You didn't do anything wrong algebraically, but this can just happen if you have an absolute value equal to an expression. So that's what we're going to check on the back. Okay, now I know I have a lot of space. We don't really need all this space for these questions. I just kind of spaced them out. So absolute value by itself, you just got to remember, cannot be equal to a negative number. Now, if you have an expression, you'll have to check to see if that expression would become a negative number. So here's all you're going to do. You're going to take your original equation. I got the absolute value by itself. You're just going to drop the absolute value and literally just copy the equation. Now, like we did on the front, I'm going to say, or drop the absolute value. So I'm going to keep the x minus 2. And then instead of doing like we did on the front, like 6 and negative 6, what you would do here is the negative of that expression. So that expression was 2x minus 10. So the negative of that, we're just going to switch the signs. So it would be negative 2x plus 10. It's just the opposite. You don't do that with what's in the absolute value, just only with what's on the other side. Just make it the opposite. Just change the sign in front of any term. And then I'm going to just solve these two equations real quick. So totally up to you. I do have variables on both sides here. I like to try to keep the variable positive if I can. So if it was me, I would probably take that first one I wrote down and subtract x from both sides. And so I'd have negative 2. 2x minus 1x would just be x, and then minus 10. And then I would just add 10, and then we'd have x alone. So potentially 8 is one of my answers. We'll just check that in a second. Okay, the other one, again, it's totally up to you. I like to try to keep my variable positive if I can. So on this one, I would actually add the 2x to the other side. So x and 2x would give me 3x's minus 2. And if you're not solving it this way, that's totally fine. There's different ways you could solve these problems and get the same answer. Like if you did your steps in a little different order than what I did, or if you use the negative variable, then that's fine too. But hopefully we would end up with the same answer. So then I'm going to add 2 and divide by 3. I'm sure you guys have already done that. So if I add 2, I get 3x equals 12. Divide by 3. My other potential answer is 4. Okay, now, this is all I tell people to do. You only have to check your absolute value cannot be equal to a negative. So you just have to make sure if you plugged your number in, would it make that negative? Okay, so if I do, just grab your calculator, like if I do 2 times 8 minus 10, doesn't matter what the number is, I got 6 here, as long as it's positive. As long as it's positive, right? So this was a positive number. That means that solution works. Okay, if I plug in 4, that was my other option. So 2 times 4, this is what my absolute value is equal to, so it can't be negative. If I do that, again, it doesn't matter what the number is. I got a negative 2. So If I plugged this in, that gave me a negative number. Absolute value cannot be equal to a negative number, so then that means that 4 is what we would call an extraneous solution. So this question only has one answer, and that would just be the x equals 8. We didn't do anything wrong algebraically. It's just when I plugged in the 4, it makes my absolute value equal to a negative, and that's not possible. Does anybody have a question? I know it's a little weird. Okay, let me squish this up. So if I do this problem, absolute value by itself, just drop the absolute value and literally just copy the whole thing. Your other option is drop the absolute value, don't change that 2x plus 5, could be equal to the opposite of that expression. The x plus 4 would just turn into negative x minus 4. So we'd have to solve both of these equations to get our possible answers here. If it was me, on the first one, I'd probably subtract x from both sides to keep my variable positive. So that would just give me 1x plus 5 equals 4. Move your 5 by subtracting it. So potential answer there is negative 1. And if you want to, actually, let's just check right now. If I plug in negative 1, you only have to worry about, you can't have an absolute value equal to a negative. So I really just have to plug it in here. If I do negative 1 plus 4, as long as that's positive, which that's positive 3, then you're good to go. So this works. So negative 1 is one of my answers. My other potential equation here, let's see. Actually, if it's me, I'm going to add x here. So I'm going to get 3x plus 5 equals negative 4. Then I'm going to subtract the 5. So I get 3x equals, let's see, negative 4 minus 5 is negative 9. Divide by 3. And my other potential answer there would be negative 3. Okay, now, if I plug in negative 3, right here, the x plus 4, if I plug that in, is that going to make that negative? What's negative 3 plus 4? If I do negative 3 plus 4, what am I get? That's not negative, that's positive. So actually this works too, right? As long as it's a positive number when you plug it into that expression, then that'll work. So this actually has two solutions, just like a lot of the questions did on the front. So you got to check. All right, just cannot have an absolute value equal to a negative. The only time you have to check is if you have something with an x that your absolute value is equal to. None of the questions on the front would I had to have checked because they were just equal to a number. Okay, we're going to try one more. And last one, this is an expression, so absolute value cannot be equal to a negative number, so we got to check our answers here. My first equation, I'm literally just going to drop the absolute value and copy that down. So 3x minus 4 equals x minus 8. The other potential way to do this, say they just drop the absolute value, but then instead of doing like the opposite of the number, you're doing the opposite of that entire expression. So that x would become negative x, and that negative 8 would become plus 8. It just makes each of the terms opposite of what it was. Totally up to you how you want to do this. If I was doing it, I would subtract x from both sides here. So I get 2x minus 4 is equal to that negative 8. I'm just going to add the 4 real quick. So you get 2x is equal to negative 4. Divide by 2. X is negative 2. Okay, now, if this is going to be an answer, I'm just going to plug it back into that expression. That absolute value, whatever that is, cannot be equal to a negative number. If I plug in my answer, I got negative 2 minus 8. Doesn't matter what it is. If it's negative, then that can't be a solution. So if I do negative 2 minus 8, that's negative 10. So that gives me a negative answer. So that means that that solution doesn't work. That's what we call an extraneous solution. We didn't do anything wrong algebraically. It just doesn't work in the original problem. Your other potential one here, totally up to you. If it was me, I would add the x, keep my variable positive. So I got 4x minus 4 equals positive 8. I would add the 4. So I'd get 4x is equal to 12. And then I'm going to divide by 4. So my other possible answer here is 3. Okay, now, if I go back, I got to check. I want to plug it into that expression. if I plug in 3 minus 8 on the right side of that equation, if that's negative, that's no good. And that's negative 5. Absolute value cannot be equal to a negative number. So when I plug that into that expression, that gave me a negative answer. And so that's actually an extraneous solution as well. So this last question here, the answer would be no solution, because both of the answers that we got made that expression negative, and we can't have an absolute value equal to a negative. So I did one of each type on the back. So if you have an absolute value equal to an expression, like the first one, we had one answer that worked and one that didn't, okay? That second question we did, both of the answers worked. And then the third question we had was neither one of the answers worked. So those are the three possible things that could happen to you while you're solving these equations. You only have to check if your absolute value is equal to an expression. If it's like any of the questions on the front, right, like each one of these was equal to a positive number. Like I had absolute value equal to 6, absolute value equal to 11, absolute value equal to 10. There's no potential for an extra answer there because I know what it's equal to. It doesn't have an X with it, with that plain number. So those all just have two solutions. If you're going through and you get an absolute value equal to just a plain negative number, you can stop the problem right there. That's no solution. If you have an absolute value equal to an expression, like these ones on the back where you got it equal to something with an X, that's the only time you have to check. And I kind of have the homework separated that way as well. Okay.